Thank you for coming to the session. This is Knowledge Graphs, Journey to the Connected Enterprise. My name is Benjamin Nussbaum. My background is in enterprise software architecture. I've been building and delivering globally distributed systems for about the last 20 years and have spent the last 5 to 10 years really focused on connected data and what does that look like in the enterprise and how do you get there, how do you define an architecture and a process and kind of change transformation that takes place around that, and what is this whole world of graphs and how does that play a part in these strategies as we go forward. So I know we've all been inundated with this conference, so I will go through this very quickly. I just like to level set and make sure we're all talking the same language and using the same vocabulary. So when I say graph, I'm referring to models that look like this, not these. These are charts. I haven't adjusted that vocabulary. It's a good change to make. Charts, not graphs. These are graphs. So we're going to be talking about these today. Why do graphs matter? It's a really important question. They matter because our data is actually a graph. It's the world that we live. And when we have connected data, we can do more with it. It's a very simple explanation, but that's the fundamental principle. Data used to be stored like this. It was disconnected. You couldn't do much with it. Relational promised to connect our data, tell us how things were related. And it did that with joins, but unfortunately that proved very costly. The more levels out you wanted to go through that connection. So it left us really short in being able to actually explore that connectedness. And NoSQL just expanded that and went further away from connections. So if you want to, it's basically like we're going to have one view of this thing, we can return that, it's very fast, but it's not really connected. We need graphs because our data is a graph. It's really as simple as that. It's just, we have our data from the world, we generate this data based on connections that we have, and so we need that data to be a graph. Graphs are important because they let us represent things, like nodes. We can have our things be the nodes, and we can have relationships be the contextual way that two things are connected. And then we can give them properties. And so that's that meta model where it enriches how these things are connected. And understanding that contextual relationship for how two things are connected is where your real knowledge and understanding and learning comes from. Without connection, you have nothing in your data. It's incomplete. So it's really when you connect your data and expand from any two things and understanding how they're connected to how they're connected to the other things and just expanding out, that you really have a foundation for learning, understanding, and awareness. And that's why big data really left so many enterprises feeling just like their solutions were lacking. We spent a lot of time going through this big data. We're putting down a billion rows a day in the Redshift, or we're storing petabytes of sensor data. And where did that leave us? It left us with a lot of data, but largely that was it. So now that we've got all this data, we need to do something with it. It's not just enough to be writing a lot of data. I think we kind of all have started to realize that, because data, when it's just stored and it's disconnected, doesn't really tell us much. It stays incomplete. So what we're going to do is transition big data to smart data. And that's the transition that needs to take place in an enterprise for you to have a knowledge graph. Because your knowledge graph is your data connected. You have all the components of it. You have everything that you need. They're just sitting in different silos. So what you really need to do is look at how do we take those steps to start connecting them. There's 3 main goals we have for our data. We all want our data to be intuitive. We want the individuals across the organization, from the DBAs to the product people to the CEO, to be able to understand what we have, the types of things that are important to the business. We want it to be fast. Data that takes hours, minutes, weeks, months to process and understand is too slow for the pace of business today. It cannot come in at that rate. It needs to be immediately accessible. And we need our data to be flexible. Business constantly changes. Your business is different today than it was last year, than it was the year before, than it will be 6 months from now. As the world has gotten more connected, there's more of these interdependencies, the rate at which our data changes and the needs around our business force that data to change have just increased. And so the time that certain models or certain things are relevant are shortened. And we just need to be able to have it be more flexible enough in the data storage and the data structures that we can iterate very agile in that regard. Additional smart data characteristics that we want. We need it to be connected. Without connection, there is no understanding between two things. It needs to be easily explored. Ad hoc queries are really important. When you're assessing solutions and looking at how do we become a connected enterprise, if you have to design your data for the types of queries that you want to run, it's going to leave you really up a creek. Because whenever you want to ask something of the data that doesn't fit in the model you initially created, you can't do it. Or it's going to take days or weeks. Or you have to go to, actually, worse yet, you have to make a software change. Go back to the tech team and say, hey, we need to be able to ask this question. Please make the optimizations so that we can do that. Dynamic graph traversal. In the world of graphs, once you've got your data connected, you really want that ability to be able to just go into it. Start with your node, start with something that you know, and look at what's around it. And be able to do that from a dynamic perspective, whether it's a data scientist or somebody that's trying to understand and explore a fraud use case or some transaction that came in. If I can just start with one thing and look out and go through those connections and what's around it, that's a really key component. Constant time graph traversal is an important one. And that may get a little technical, but that gets into the nature of how the data is being stored at a storage level. If you have a graph store that relies on indexes, you still have to do joins. And when you have to do joins, the further away you get from the thing that you're looking at, the longer it takes and the slower it is. There are databases out there in the graph space that do constant time traversals, which means I can start from one node and go without any index to the nodes adjacent to it. And they do that through memory pointers, which is a really phenomenal design, because to follow a memory pointer in computer time is basically nothing. And so on really small commodity hardware, you can do over 4 million node traversals per second per core. These are just some of the metrics that you can get when you start to explore and examine the graph. So those constant time traversals are a real key component to consider when you're looking at the design of your knowledge graph and your connected data architecture. Graph patterns, contextually relevant edges, those are really important because in a graph, the way that you think about your data changes. You now have an edge where you can represent properties that say how two things are connected, such as if Ben likes the matrix, or Bob loves Ann, how much does Bob love Ann? Or maybe there's like an amount, or 0.8, and Ann loves Bob 0.2. So that's an unfortunate situation. She's not crazy about him, he's kind of crazy about her. But now we know a lot more than just a binary on-off relationship, that they love each other, right? Similarly, you could do a confidence score, right? How confident are we that we know these two people met? Or how confident are we in this answer that we're giving? And those come from the machine learning, the algorithms that analyze the graph and can be fed back in. So a lot of times when you have learning and AI that's processing the graph, you're updating the relationships as a result from that computation. And then that can be taken into account as you do the traversal through the graph. Another element is easily understood by the non-technical. Some graph databases that are graph layers on top of existing data stores, they're still very technical in the representation of the graph data. It's not necessarily intuitive. I've seen a lot of being a practitioner in the space, I've looked at a lot of the different offerings. And the ones that tend to unify the business the best are the ones that have really sensical representation of the data where you're dealing with things. People understand relationships. When you can get up on a whiteboard and just talk about the elements of your business with a non-technical and a technical together, change happens in the organization. It increases the rate with which you deliver, with which you advance, and it decreases the amount of error and misunderstanding that takes place. An immediately accessible graph changes everything. When you can access your connected data immediately, meaning index-free, I can do ad hoc queries, I can move through my graph, I can traverse it and find what I need and look for patterns without having had to design the storage for that from the beginning. Your organization now is flexible. You can advance and move more quickly as you find different needs and different ways to use your data. It will become a valuable business asset. There's a lot of graph components that I'm sure you've all heard about so far this week, and that for a while even caused me confusion as I was trying to make sense of all the different offerings across the different vendors. And in looking at it, I categorized it into these, and you could add a fifth one that would be, visual as well. But essentially, you've got your ingest. That's your ETL. You're bringing in your raw data, unstructured, doing your cleansing, kind of all of that processes, which most enterprises have today. And then you get to the storage layer. And now you're looking at, well, what are the storage models for graph, for my connected data? And then there's the semantic layer, and that's if you're using RDF representation or some kind of semantic knowledge representation, that would go in there. And so storage and semantic are important to separate because often everybody just says graph database, and it's either an RDF graph or property graphs don't support RDF, et cetera, et cetera. But RDF is actually a specification. It's not a graph database itself. It's a way of representing data. It's a model. It's not actually doesn't actually deal at the storage level. And then compute is totally separate. It's Spark or something like that. Typically in memory, how do you offload a bunch of analysis to do the processing of your connected data? We're going to hone in on storage and semantic because these are the two that I think are really key to tease apart, especially in making technical decisions around what does our connected data architecture look like. Yeah.
I'm sorry, you mentioned ingest and you referenced that to ETL or ELT and then storage and semantic.
ETL is typically a process, extract, transform. Yeah. Yeah. What was the question?
I just wanted to make sure that you said ETL when you mentioned.
Yes.
That's that.
Yeah. Ingest would be ETL. So on the storage and the semantic model, really it's good that you don't necessarily have to choose. It's interesting. There's RDF is a semantic model, and it's stored as a triple store. And so you'll see different vendors offering RDF stores, but really that's a triple store. And there's many ways that you can implement that triple store. So most of it's about the shape of your data. And when you're looking at how do I pick what database do I use at the storage level, you want to look at, does it fit the shape of my data? If a vendor is still using an RDBMS system underneath your connected data, it's not really optimized for your connected data. So RDF can be stored as triple or property, and those are graph storage models. The benefits of an index-free native graph property storage model is that when so I should back up actually, I want to talk a little bit more about this. The RDF specification does have, how many of you are using that today in your organizations? Handful, 5, 6. So if you're using that today, it has a lot of tooling around it, and it's been, very popular for knowledge representation. So it's really great for enterprises that have adopted that. Fortunately or unfortunately, in looking at the RDF storage solutions, they're typically not optimized for graph traversal. They're not that dynamic structure when they're in a triple store format. It's just based on what I've seen from the vendors that I've explored. I don't know of one today that actually is made for optimal graph traversal where you can put your triples in it and just bounce through the graph and go many levels down without it taking minutes or hours if you get too far out. When I think of real time, I think of immediate. Like I send a response, I send a request, I get a response within a couple seconds at most. So for me, real time isn't minutes, hours. It's not real time. If you're an analyst, you're exploring the data that interrupts your workflow tremendously. When you bring your analyst's work time down to immediate, it will change the way that they work. It'll fundamentally change it. If you're starting fresh and you don't have an RDF schema in place today already, you have a bit of an advantage in that the property graph model is actually an implicit representation of your knowledge based on the way that you define that data model. Because what happens is when you look across all of your disconnected data sources, and they all have their strict schemas, and now you want to connect those, that property graph model will be your unifying model of knowledge. It will represent and show one common way to represent the person, and it's flexible. You can have all these different properties, let you show how, it'll basically, as your data flows from your disconnected data sources into your unified property graph model, it will show you your complete picture of data for the organization as a whole. And it will connect those points where, oh, there's this person here, happens to be the same person here, happens to be the same account here, etc. And so if you're starting with a blank slate, you have the option of, you could go the RDF route, or you could just go the implicit representation in the property graph and still define the same vocabulary. Because as you model that, it will create your vocabulary for you. The benefits of that property graph model, you're interacting with the data in its true form. It's very intuitive. I've watched very non-technical people explore the graph, go through it very efficiently, just from some base starter queries as they're going about their work. Because in graph, you're thinking about patterns. You know, you're no longer dealing with joins. You're thinking about, okay, how does this data connect to this data? What are those contextually relevant relationships? And so in those patterns, you can explore the graph and you can give queries and distribute these to the different team members and give them a place to start where they can expand. Whenever your data is intuitive and you're not thinking about, oh, how do I get this data? How do I join this together? Kind of go find all of this stuff. And when you stop massaging data, your developers get a lot more done. It's a lot more productive. So you'll build more faster. I've seen this. I've led development teams. Some of the things that they've built in the periods of time that they've built, it's just been incredible. And I attribute a lot of that to working with data in its true form. When your organization starts to understand all of the connections across all of the silos, you can start to have much better multidisciplinary teamwork as well. And we're going to go into a little more detail on that, but the non-invasive way of introducing a graph is really important in the architectural way. It's how do you get started? When data's not stored in an intuitive format, you just spend all of your time doing joins and trying to figure out how to get that data into a format that you can work with. With a graph, your data is really represented like this. Literally, in a native property graph model, what you draw out on the whiteboard will end up going into the database exactly like this. And so in this case, maybe you have a person that looks at this product, and you're also connecting out to past purchases, to inventory, and as I'm going, to the shipping, logistics, location, their social media, you can start to see this is what a connected customer looks like. When you get into that connected consumer, it's no longer just about what demographic do they fit. It's, I have this node that represents my consumer, one single consumer. And now when I do learning and reasoning and look at them, I can look at them as an individual instead of just doing generalized machine learning over an aggregate and drop them into a population group for what they might want. I can look at and build my algorithms so that I can understand them as an individual. And that becomes really powerful. As we apply this pattern, building solutions around the connected consumer, the quality of the interaction, the experience that that consumer has, becomes so much better. But you can think about all of the systems in your enterprise that are touched by these simple nodes, where you look at inventory, logistics, all of your supply chain. When you bring that in, and you can interact with that in real time and be able to have a real-time algorithm as a consumer is going through, let's say, a page to browse your shopping as they're shopping, you can immediately hit the graph, the connected view of your enterprise, and make decisions based on that. The data isn't stale. And so when the data is in this level of understanding, it changes the game for the enterprise because it brings everything to more of a real-time touch point. On the developer productivity, when you're dealing with connected data, you need a language that is intuitive and built for that connected data. One of those is Cypher. It is by Neo4j. They've done a lot to advance the graph database space, and Cypher has been adopted by Oracle, and I just saw in Emil's keynote that he mentioned HANA from SAP also supports it now. The intent with OpenCypher is to make that the query language for graph databases because it's designed for graph traversals and graph pattern matching. And as an example here, what you see on the left is a SQL query to join together and basically do a data hierarchy for a management reporting chain. How many direct reports are there? How many reports do I have going down through the organization? On the left is the complex join that's required in SQL. And on the right, and this actually comes from a customer use case, is what it would look like in Cypher, where you're simply, it looks a little bit like ASCII when you start getting into it, but it's, match is how you start your query, kind of boss is the node, manages, and then if you want to do depth-based traversal because it's native graph and you can just step down through from one node to the next without hitting any indexes, you can simply say, go start with this guy and look 3 levels deep, look 4 levels deep, 5 levels deep, and get everybody that he manages. And then go and get all of those people that are managed in their reports. And then we can roll that all up. When you're able to start in a graph, start with one person and go down or up 7, 8, 9 levels. If I try to do that in SQL, it's just like, no way. But with connected data, when you have index-free traversals through the graph, and you don't have to hit indexes to build these lists and then filter things out, you can write queries that are super complex in just a few minutes. And that is a huge advantage when you're trying to get your teams to push out product, build things faster, work with the data that they have to surface insights to the business. Cross-functional collaboration. This is another huge benefit to an organization because the change within an organization when you're looking to shift your paradigm and you're thinking to connected data, it's not just about the technical. And one of the big benefits of graph, especially the property graph model, is it lets you work from CEO down to the sysadmin. You can all speak the same language. When I go into an organization and I stand in front of them and we get on the whiteboard and we start talking about what is your data? What are these concepts? That are important to your business? Okay, you have people, you have accounts. So you have Bob, you have his account number, and then he has this, he does investments, et cetera, et cetera. And everybody can sit in the room, the product, the business, the developers, and everybody can look at that and discuss it together and say, yes, this is actually how our business functions. Then you've changed your organization. Because prior to this, for 15 years, whenever I would go into an organization, I would talk to the business folks. They would say, yes, these are our requirements, this is what it looks like. I'd be like, great, got that. I'm going to go turn this into third normal form and bring this back to you and make sure I didn't miss anything, right? We're going to try to talk about this model, make sure it's representative of the business, it's flexible, it lets you expand in the ways that you need to, that you're anticipating to have it change. And the business folks look at it and like, yeah, seems about right. And then you get 6 months down the road or a year down the road, they're like, oh, that doesn't actually work the way that it was supposed to. This is really slow. And I'm like, well, I didn't know I was going to have to actually put these two things together ever. And they're like, well, no, we told you that. I'm like, oh, okay, go back, redo the work, come back around. With this, what you end up with on the whiteboard is what goes into the database. That goes into the storage level. And so it improves that room, or that collaboration and just the level of communication within the organization, and allows you to run faster, make these decisions, and know that they're getting implemented without that confusion the first time. With any existing enterprise, there are many systems at play, and to introduce a new technology can be scary. Fortunately, with graphs and with the native property graphs that are out there, you don't have to do a rip and replace. The way that we typically do this is very low risk, non-invasive. So whenever you're in your organization saying, how do we go about this? Just know it's non-invasive. You're not tearing out any existing infrastructure. Day one, you're going to plug in your graph next to all of your existing systems, and you're going to start cycling data into it. It's going to go through a transform process. It's going to load, land in that unified model, that graph model, that connection that represents the whole perspective of your enterprise. Day one, it won't be the whole enterprise. It'll just be the first piece that you are bringing in. Because if you sit down and try to do everything at once, that's a large endeavor. That's a big lift. But if you start with one database and just convert it to a graph model, or two databases that you need to connect, find one starting point and get that first one done, and then build the applications that are going to do the real-time interaction with the graph around that. And so that way you can start proving to the enterprise, yes, we can do this. We can work with connected data. We can bring all of these legacy systems together, and we can be successful at this transformation as an organization. And then start the data flowing in. And as your data flows into your existing databases to the graph, and your real-time systems are interacting with these, as you build that trust, you'll start to have more and more applications use the graph, and you'll start connecting other databases. And then eventually, as the other systems that are using those databases directly reach end of life, you can even start to retire them. They're assuming that you choose a graph database that is ACID, meant to be a source of truth database. Those last few slides, they sound like really simple direction. It's, we're going to have cross-functional collaboration, improve developer productivity. We're going to get our data connected and flowing. If you've never gone through that, it's going to be really challenging because there's going to be a lot of naysayers inside the organization. There's going to be technical hurdles. There's developer mindset transformation that needs to take place. If everybody's worked with SQL their whole lives and now they're like, I have to learn this new thing, how do you do the training? How do you equip? How do you build up your internal teams for this transformation? It's not just a technical choice. It's a complete paradigm shift. Thinking that, yes.
Don't forget Mr. Murphy.
Mr. Transitioning to think and graph it's a different mindset. One of the biggest mistakes I see developers make is that they pick up a graph database and they treat it like a relational one. they don't use the patterns at all. Because in graph, when you're doing index-free traversal, the patterns are your friend. You want to use patterns in your data. It becomes more about the patterns in your data that are important, rather than how do I join these together. So if you go and get set A and get set B and just do a where clause and filter it out in a graph, you're doing it wrong. If you can filter with a pattern, at least in a native graph, it will be faster, much faster. So graph thinking is a huge paradigm shift, and one that can be helpful to have some help, but it's one that's never made more sense. This is how the brain works. So I think for me, my aha moment, whenever I started working with connected data, graph technology, I really, after having done the first project, I kind of had this aha moment where I started looking back at all of the systems I'd built and all of the systems I was being asked to build, and I said, I'm trying to put a square peg in a round hole. The data that we're dealing with is connected. And this is how the brain stores the data. Emil has a much nicer slide for the brain and the neurons, but it's how the brain thinks, it's the patterns. And so when we can represent our data in the same way, it's just very intuitive because that's how our brain is used to experiencing the world. I experience the world as connections and sets of relationships. Like I have a relationship to my kids, to my car, to my phone, to my like we all have these things, and there's different ways that we relate to them, different meaning and context about it. And so that's how the brain is used to working. It lets you solve really complex problems very efficiently. One simple example, in a native graph where you can traverse between two things, doing a shortest path algorithm is very simple. You take two nodes and you say, show me the shortest path between these, and it'll complete sub-second. You don't have to implement this massive, painful thing in SQL, which I've had to do, and it's not fun. I'm sorry if anybody else has experienced that. But these complex traversals and questions that we want to ask of our data become very simple. Improved collaboration between teams and everyone else. So it's not just the technical that know what's going on, but it's the product and the business level can have that insight and participate in the data of the enterprise. And the flexibility to evolve your data. That's one that shouldn't be overlooked. I haven't talked about it too much, but having a graph that lets you flexibly change your schema and evolve your data as you need to is a huge benefit because your data will change. And the way you need to store it and think about it will change as your business changes. So these last few slides are just kind of some lessons learned from me in different organizations that I've gone into. Don't go it alone. If you're an organization and you have developer teams and you're very efficient in your software process, that's wonderful. Keep doing that, but let somebody come in, let an expert come in and help you go through that training, that thinking. How do you actually build with connected data and work with it day in and day out? Let them build the first one. If you're trying to hire and organize a team around this, you definitely want to build that internal capability, but it won't happen overnight. So I've seen a lot of challenges trying to go it alone internally, as well as just giving it to any old vendor. Everybody and their brother will say, yes, we could do this, right? You got Tata, Infosys, Accenture, Deloitte. They'll all say, yeah, sure, we could work with Graph. And then what they'll do, and what I've seen, because I've been around some major telecoms, globally, financial institutions, etc., where they're bringing me in to look at their connected data, their graph database initiative that has gone sideways, that's a year old or maybe two, and they're just like, how do we get this back on track? How do we actually push this into production? And I look at it, and I'm just like, this was obviously their first project. They'd never done this before. And now you're sitting here as an enterprise having a multidisciplinary team of 20 people running a year and a half over I think it would have been better to just start with an expert at the beginning and get some guidance. Let them build the first one. Your team will learn as you go, as they watch how working with connected data is done, and then they'll be able to do it and take on more and more of that. But it's such a paradigm shift. I mean, in some of the trainings I've given, some of the most seasoned SQL developers are the ones that struggle the most because they're just like, what do you mean patterns? I don't get this. I don't understand why we're talking about data patterns. Why is this important? And so I think be wise in your selections of how you pick your technology. So hire a professional team that has experience in connected data. That's probably the best thing you can do for your first time. Like, it will save you so much money in the long run. I promise. So the first thing to do is just get started. Whether you're get a POC, pick one area in your business that you want to connect. Look at how you bring that together and start building out that model. Start working with somebody that can help guide you through it. And just get started. But in summary, pick that first one. Use an index-free native property graph storage model. I've had many people just say, well, the only one that we know of is Neo4j and it doesn't scale. Totally not true. I can talk about some use cases where we've actually connected it to pretty big pipes of data and flowed it continuously. That one's really important when you want to do dynamic graph traversal and actually be able to go through your graph. When I talk about connected data architectures, it's not just a graph database, but there are other components to that can be put in as well. So it's how do you actually design that architecture. That's often what I end up helping with, is just looking at what are the existing systems, how do we need to put this connected data architecture in place and bring it all online and make it work very efficiently. Engage your non-technical from the beginning. That'll be one of the best things that you've done. I don't know the mix of technical versus not, but get both sides involved in the conversation. The non-technical will love the graph concept because it will make sense to them. And that will pay dividends as you go through this endeavor together. Questions?
Earlier you mentioned that the customer's existing relational data gets pulled out and put into the graph system. I can imagine that causing a number of problems, including the data being out of sync and whatnot. So what problems do you see when they copy and keep it updated, et cetera, and what techniques do you use to deal with the fact that there's duplicate data?
So usually so if you have an ETL process coming into your existing data store, right, now you have structured data in those existing databases. There's also, in our architectures, we typically put another layer of extract and transform and load between the structured data sets, so the RDBMS, into the graph. And then the extract and transform can happen on whatever schedule is needed. So if it's real time, as soon as it hits, we update it, we push it, and we send it to a queue, and it consumes, and it gets on the bus, and we write it in. We typically deploy graph stream, which is basically just a write pipe that we can point at our graph databases and just flow the data in. And so we can set up many extract workers that can take from the different databases, do the transform, and drop it onto the pipe, and then it just flows in. So it's kind of a separate ETL process to go from structured data into graph, and then you can set your schedules accordingly. And you do have to account for deltas and deletions, kind of all of those things as well. But the graph model, day one, is meant to stay synced with the existing RDBMS that you're essentially cloning from to start.
You mentioned at the beginning on the compute side, so the Spark might be used for So can you elaborate on this? What are the use cases to work with Spark and Hadoop?
Yeah, so on the compute side, we've done Spark GraphX has support for graph structures, and it'll let you basically take your data, put it in, and do analysis in the graph form. So if you have a lot of data that you need to just push off to compute, you can use Spark. Another way that we've done it is we've actually, it's actually really interesting with one of our Neo4j deployments that we ended up doing. We built kind of a native graph compute where we actually ended up scaling out these Neo instances and had a whole job framework that, because we needed to do a lot of complex traversals, which would cross maybe 100 million nodes, and we didn't want to ship all that data to Spark and then bring it back. And so we built out, basically added a consumer on each one of the Neo instances so that it could consume the job, do the processing on the graph that was on that instance, taking advantage of the native traversal speed, and then ship it back to basically that graph stream and pipe it back into the master and go back into the cluster and everything updates. So it was actually worked pretty well because we didn't have to pay that data penalty for moving it to Spark and back. But so we've done both.
That's the major concern. You have lots of data, so it should be back and forth.
Yeah, that was why we.
So storage plus the time.
Yeah, exactly. Yeah.
Earlier you showed us a query, right, where SQL versus Cypher, much simpler. Do you have any comparisons between Cypher and Spark here? If that you know the represented.
That's a good question. I can find some. I don't have any in the deck or handy, but what I've seen and what in my exploration of Sparkle is Cypher is shorter and simpler because Sparkle is still built for kind of SQL and joins and going and getting the data, so it ends up being a longer form for connected data. Yes.
One question is, you had the slide where you showed, you have that graphical representation, I think, of the retail example.
Yeah.
But it seems to me, how do you, customers can make bad decisions with good data, right? I mean, in the sense that, you had an example, I was just looking at it, you had the example of, I think a blender or something, mix master or something.
Yeah.
Let's say you buy one mix master, you may not buy another for another 10 years, right?
Exactly.
So I guess my question is, your graph could show the connections, but how do you get the knowledge in there the correct way that these connections have value? Our brain, as you mentioned, thinks about relationships, but a lot of the relationships, our mind throws out a lot of stuff where the closeness is of no value. Right? So the relationships have to have prominence or some form of weight, right? So
Exactly.
looking at that slide, I was just thinking, well, okay, yeah, I can see that you could build one and you can show lots of really good relationships, right? But there could be tons of relationships around that node, but that node could be completely worthless in the sense that I'll never buy another blender or
Correct. And so I think that's where the graph actually pays a lot of dividends. We have.
Does that make sense?
It makes complete sense. We often use, if not always use weights whenever we're trying to build recommender systems. And what you have and what you see in the blender maybe isn't represented there is, I would suggest that there would be additional knowledge about frequency of replacement around that blender. And so if somebody is buying one, I don't immediately want to say, hey, you should buy another one. Like that's a very simple model, or simple way of thinking, right? In terms of, if they bought this, they should also buy this other thing that's exactly the same thing. We have more advanced models that I guess for retail use cases specifically that we can talk about offline. And that was a specific interest.
But I just was wondering how you help your customer make more intelligent decisions and not just, just because it's graphically represented doesn't mean that
So
the data has value.
Correct. Behind the graph, and whenever you're building the knowledge graph, classification is very important, and defining your traits. attributes, whatever you want to call them. You will have some base. So if you take a movie example, if you have The Matrix, and it has genres, and you have The Notebook and Gladiator and these other things, and they all are connected to these genres, well then, if I start with this movie, how do I recommend this other movie that you may be interested in? There's some examples online that you could take a look at how this is working that are powered by this graph recommendation technology, but a lot of it comes down to the data that you put in. And so then as you build reasoning engines, or like inference engines, those will run on the graph, and they will update those relationships. That's where you'll get those values of the weighting.
So then those graphs will change dynamically. That's your point.
Correct. Because the knowledge graph isn't static. It comes in and it's like that to start with, and then you start building your learning engines, your reasoning, your inference. You look at how things are connected, and you bring those results from that back into the graph, and you update the edges that are impacted by what you learn from that reasoning and those inferences.
Along that line, that's a good point you're making, is you could also identify pockets and clusters that will allow marketing to draw conclusions. So in one context, that connection may have absolutely very little value, right? Because they bought something within the last 10 years. But when you're looking at it across a very large number of members of a population that has sort of similar profiles, and that is contributing to a greater value. You see what I'm saying?
No, I agree, but I'll give you an example. I mean, I bought a table saw online. Okay, so you buy a table saw online, you're not going to buy another table saw for another 10 years.
Yeah.
But you're going to buy a dado stack, and you're going to buy, a bunch of other stuff to support the table saw. But you wouldn't see some of that. You won't see if I were skill saw, I don't sell the other stuff, right?
Yeah. You won't see it through just your connection to what you bought,
Right.
but maybe you'll see it through that thing that you bought, its connections to everything else that goes with it based on the job it's meant to do. So essentially, if you have a product catalog, there's a knowledge representation. Or if you're a general store that's doing e-commerce, and it is lunchtime, so if anybody wants to go out, feel free. But if you have that general representation, you can start to build out the knowledge of how these products are connected to each other and how they are used together.
Correct, and that was what I was trying to get at, is that some of the things may be orthogonal to what, just because you sell them on Blender, you may not sell them any other appliance. You may find out that what you're going to sell them is ice cubes and limes or something, because they're going to, make a daiquiri. You may want to, does that make sense?
Yeah, absolutely. And I think that's just where you're building out that knowledge base and that understanding of what those things are.
Yeah.
I think you mentioned you work with financial services companies. What are the biggest challenges in financial services?
So
What are the biggest challenges you see in financial services in terms of implementation?
Oh, and financial services? I think it depends which types of financial services. Just the default one is just the amount of regulation around it. And I know at least in the banking sector, it's not uncommon to have banks that, with all their different branches, have their own data, and especially if you start crossing country borders, they can't share it even within the bank. So I think just breaking down some of those regulations in terms of how you get the data to a singular view is a challenge. But not one to be solved technically, but more of like the organizational challenge. Good to know. All right. Thank you, guys.